So we're talking about the interaction between research and business in Latvia. Now, my own background is in business. Most of my business life was in the US, much of it for a large company where I worked in long-range planning, among other activities, and I also was involved in bringing new technology into the company from universities, R&D companies, and others. But I was also in a role similar to you. I was executive director of the Technology Transfer Society, which is worldwide. We included as a corporate member King Abdulaziz University in Saudi Arabia, HP, and many major companies. Anyways, we'll get into the presentation. I will talk about photonics, what it is. It's still a mystery, I think, to a degree. And we'll talk about our innovation ecosystem and the idea of Fotonika as the hub of this system. And why photonics? And here's the laser pointer too, okay? Why photonics is a smart specialization for Latvia, even if our government doesn't quite realize it yet. And then we'll cover a few other items. Now, what is photonics? I think the key is the control of photons, the arc-quanta of light, to achieve human objectives. That element, I think, has to be in there to govern it. So that covers the research and the business aspects. So it includes all of classical optics, optoelectronics, and quantum technologies. It is also a key enabling technology to sustain competitiveness. And this, in part, is because of the major role of photonics industries in Europe. You're looking at over 20% of European GDP is photonics related, so it's very, very key. And it is the field of research of our research association. Here we see the very large potential of photonics, and it is also the key enabling technology for which Latvia, with its small size, is particularly suited, because photonics lends itself to small, research-driven businesses, which will happen in Latvia. We will not see mega corporations here. Photonics is present everywhere, and this is a science map of photonics research concentrations. So we're kind of ever-present everywhere. And again, many, many products. And here's our photonics innovation ecosystem. On the left are companies. On the right is research. And the hub of this activity, as I see it in the future, because this is coming together, this is a vision, is Fotonika-LV, the National Science Center of Photonics in Latvia. Now, we can drill down into these, no need to read them all, but what we're looking at is a group of institutes which are headed by well-published people and do incredible research. So we got, within Fotonika itself, we've got the Institute of Atomic Physics, Laser Center, and then within this Institute of Solid-State Physics, 40% of their R&D work, according to their director, is photonics related. And there we have the Laboratory of Optical Spectroscopy, Semiconductor Optoelectronics, Solid-State Radiation Physics, Optical Recording, and Amorphous Materials. And then in Riga Technical University, there's the Division of Radiation Engineering Physics. And then we also have the Innovative Microscopy Center at the University of Daugavpils. In space sciences, and this goes, we're repeating a little bit, we have the Institute of Astronomy, the Institute of Geodesy and Geoinformatics, and the Ventspils International Radio Astronomy Center. Now this is one of the larger radio telescopes in Europe, and so we have infrastructure, major infrastructure, in this Schmidt telescope. I think it's one of the 10 largest Schmidt telescopes in Europe. Our Riga satellite laser ranging station is significant because not only is it part of a very important global network, but the design of the satellite laser ranging in Riga is used by many other satellite ranging stations around the world, because the technology first originated here, and the first station to pick up Sputnik was here. And then in quantum sciences, we have one group headed by Dr. Ambijns, and he is a European Research Council grant winner. Another group is by Professor Kashchevs, who was top 50 scientists named last year at Davos in China. So we have very credible capabilities. The research performance out of these groups, we're looking at 45% of the research publications out of Latvia relate to photonics. When you follow these definitions, when you just look at optics, photonics, etc., it's 32%, atomic, molecular physics, and quantum sciences, 29%. When you merge these together, 45%. So there is and total papers, we could look at that. So very significant output, research portion of the Latvian scientific output is in photonics. Now the economic performance, we are beginning. These are SMEs. Our total turnover in 2013 was 54 million. I think 2014 approached 70 million per my recollection. And so we're looking at 700 employees in 2013. And then in addition to the 21 startups that result in that count, there are 6 additional startups that have no significant turnover as of yet. The total turnover across our own region is about 150 million. So we can look at outlooks. What do we do with this? Because we have credible science, we have businesses that are growing. The historic growth rate is 15% plus. So I define the scenario business as usual, continued underfunded research, and no particular priority for photonics, or photonics is recognized as an area of real opportunity. State R&D funding becomes adequate, and there's active support for growth of the cluster. So how do we grow clusters? Well, key in our case is university-industry collaboration. Now MIT, and there's other groups that have studied this problem, you need a shared vision. You need to engage leaders that can cross the boundary between industry and research. You need to create a shared platform to exchange ideas and information. You need to clear agreements on IP, and you need to invest in long-term relationships. Now, Fotonika is operating in that. The grant has enabled us to function in that role, to be kind of the convener and the promoter of photonics. Our vision is to build a world-class research-driven cluster in photonics, quantum science, space technologies, that becomes a principal driver of economic development during the period 2015 to 2030, with a strong impact on our neighbors. And the National Science Center Fotonika leads this development. And we do have, within our project, here's what we've done. We've organized conferences and exhibitions that feature SMEs. I believe there's 5. We promote Latvian SMEs at conferences where researchers present. I've done that in 2 cases. We also have had 81 colloquia, and SMEs are invited to these. They often come, and they frequently have presented as well what their technology is and so forth. We also have regular counseling on Horizon 2020 and other funding opportunities, Fed Open, SME Instrument, other ESSA, and even early stage venture capital. We've given advice. We also have provided direct support, I think it was in 5 instances, of actually helping folks write grant proposals. And we had one of the early successes with Baltic Scientific Instruments, and I think there are 2 pending right now. And we also encourage new venture development. The commercialization reactor process in Latvia has brought, I believe it's over 30 companies have started in Latvia based on technology from the former Soviet Union. We invite a researcher here, they're joined with an entrepreneur, and they're joined with financing, and they start a company. I've been told by the head of that he believes we could have 10 to 12 new photonics businesses in Latvia through that process per annum over time. So what is an innovation ecosystem? It is not Soviet down central planning. We have learned that does not work. The European Commission says we can't do that. We can't push a specific company, specific sectors. But how do you promote innovation? So it involves research management, economic development, effective communication. It is self-organizing. All these entities, you have many entities, they have to work together, no top-down direction, but they have to achieve the national goals. And basically, this word, quintuple helix, is a word that says you got research, you have industry, you have the public sector, you have civic society, all working together somehow. You know, no top-down direction, it's bottom-up effort. And so here's the idea. You can't just talk about clusters, you can't talk networks, organization that's static. The idea of an ecosystem, it is a living thing, and there is a clear focus on individuals to stimulate and foster innovation and invention. Also, place matters. There are people who talk about virtual innovation ecosystems, but the problem with that is you don't meet face-to-face. You need face-to-face meetings. You need people that say, I will form a company here. And that's, so Latvia matters, and this is it. So here's, innovation is a chaotic process. And there is a chaotic, the tractor can provide order to a chaotic system. This means we can get things like this. And a tractor is called strange if it's a fractal structure. This is a fractal structure. It branches out. And so the NSC Fotonika is the strange attractor for the photonics innovation ecosystem in Latvia. We provide the way for all these disparate elements to work together to achieve the breakthrough. And then we got, here's, well, you've heard many, many things about what we are, the National Science Center Fotonika-LV. The core of this innovation ecosystem is a hub. You got all these others, which are not top-down, not directed. They work together to achieve a national objective. And here's, several years ago, Latvia was trying to create a national research operations. Well, Photonics is the 10th. There are 9 others. Right now, no one recognizes that outside of this room, but I think if we, like Carlos, win and Photonics is recognized, we will have that. And this, which is organizing us, is linked to outside entities, international partners, and certainly business is all part of it. So what is smart specialization? It's focused on what a region is good at doing to accelerate economic development. It's being smart. It's coordinating investment to stimulate innovation. It's collaborating industry, government, education, and research. And it's attracting, which is very, very important, attracting and retaining quality people. Our project has attracted and retained some quality people for Latvia. That needs to be expanded, and it needs to be a model for the whole country. And we need to innovate, and that means transform knowledge into growing wealth. That is our emphasis. So we specialize in Latvia to achieve economic breakthrough, and I believe photonics is the way to do that. If photonics meets the criteria for smart specialization, it really, to a degree, does not matter what the government has come up with. So photonics has the potential to drive economic breakthrough. We have the number of researchers they have performed, and there's huge market potential, numerous niche market opportunities for startups, and so with high growth of 20% is not uncommon. There's very high potential for cross-border collaboration. We already have 12 international partners, and we need an innovation ecosystem to drive the breakthrough. So, and then we talk about the system needs to be chaotic, not top-down, not Soviet planning. There's some other elements here. Very, very important is foresight, a foresight process, because innovation comes from recognizing where the future opportunities lie. So foresight needs to be integrated, integral to the process. And so that's what we've done. We've gone through some foresight exercises in Fotonika, and we have developed our vision with that, and we will further integrate that in the future. So here's some more of the process. Measures: revenue, growth in jobs, growth in firms. This is very, very important, and we need to concentrate more on that. Increased investment, value and number of R&D projects, value and number of patents. We have concentrated too little on patents at this point. We've done a good job on publications. Here's where Fotonika has a lot to offer, because when the same researchers that work on space science and on outer galaxies, the same kind of education you need for them, you also need for the guy that's working on designing some high-tech instrument. It's the same thing, the same optics, the same physics. So you have a common education for basic science and for industry. And that's one of the things about the triple helix that we offer. And that's why photonics is very important for Latvia. And then, of course, the cultural factors that augment. And again, I can't overemphasize the importance of foresight and thinking about the future. And it can't be like you say, our smart specialization today is this, because next year it may be different because you reassess the future and you reassess it again. So to say that in this year's Latvia's smart specialization, you can't find photonics at the top level really means nothing, because next year it may be there. It is flexible. We have to be flexible. So work in Latvia, photonics, and here our fractal has grown. Well, we're looking at a cluster. I think this is possible, very doable. Over 200 firms employing over 5,000 people, turnover over €1 billion, 300 to 500 researchers with an annual budget of 100 to 150 million euros. That is our future. We need to get busy and work on it. So, thank you. Thank you, Dr. Ubalis, for making this opportunity possible.
Thank you very much, and especially for economy of time. Now we have time to discuss. Is there some questions? Some comments? Yeah. Question. Okay.
Do we have specific technologies that can be commercialized as a result of the project? I think we have some. We have actually, I think they're incorporated in a couple of the SME calls, SME instruments. One of them has been funded, received funding. Another one there were...
What I need is going through another report. Outcomes where you can put already venture capital.
Okay, yeah, I'd say one particular project to me looked very promising, and I initiated a discussion with the venture capitalist on their particular project. It needs to be brought forward. So I would say we have some. Yeah. Well, in this particular case, the one that looked to me actually very intriguing was a mobile SLR station, which was able to pick up, because of its construction, you would need fewer reference points. It is mobile, it's self-contained, and to identify among multiple incoming objects or objects you could identify and track individual objects, it appeared from the write-up much better than anything out there in the market. That looked to me quite promising, with actually multiple other applications possible. So that's one specific. I think on the other possibilities would include I think something on the coding application, the SME application. That's the first stage. So that's a study. That's not a not a technology readiness level, whatever 8 or whatever up, where it's ready for looking at venture capital. So I'd say at this stage, I don't know, Arnold, you probably have some other ideas. I'm a more recent newcomer here, so.
I can add, thank you for a very reasonable question. Firstly, what we can state now, hopefully could be nice, but evidently there will be no single Nokia in Latvia. But I made some studies during the crisis in 2008, and I simply asked to this, having knowledge about how much we have so-called knowledge-driven and science-oriented SMEs. It's about 20. I selected them looking about their capacity to fight and to be invited in various consortia for framework program with clear criteria that they are demanded. I also made a selection criteria that they have enough turnaround, about 1 million, and they have some niche in Europe or in world, saying that, okay, we have about 5-6 competitors, but we are in a very specific niche. And I said to them, okay, let's count. Do you have your own projects, not Socrates' bed from Greek mythology, but your own project idea with your own project design? And please tell about if you suddenly have not investment, donation from structural funds about 1 million, which is a real practice for framework programs. They are donating to small middle-sized enterprise such money. Can you raise projects? And they each responded to my question, and I collected together saying that you'll be very careful with your forecasts, and still they said, okay, we can cover world market in high tech about 2 billion. Unfortunately, state government was not able to find 20 or 30 millions of structural funds to take a risk to go with such enterprises and to start to do something. And of course, they, by their own, their message to us and to me and to government was, no, there is a crisis time. We are in the high-tech niches which are stable in spite of crisis, but we are not going to take a risk with risk capital. We are even not going to take a risk with loans. And that is a message that then if you have such potential, that they are very, very careful to do something to expand, then you need to put public money because you have potential. This decision was not taken, and its Technopolis said that we have very stupid research and innovation policy.
I think we have Dr. Spiegelis in Biophotonics has about 5 inventions that I believe show great promise. I was also at the commercialization reactor meeting some months ago, and there were 6 photonics-related initiatives that are they derived from our project technologies. I would say they're related, but those have already received startup funding. Okay, so it looks promising to me, and I think more will come as we work more closely with the SMEs and startups, and as an institution, help them, take those steps in preparing the grant proposals, understanding how the EU works, and also how business itself can work. The commercialization reactor process includes business acceleration. We have discussed them using our facilities for meetings and things like this to bring that in. So that's another way of tying in and making the ecosystem to work. But so there are multiple opportunities out there outside of the grant system that are already have been funded. Actually, they've received startup funding.
Yes, you asked about real example. Real example exists and is still. I noticed this company Zetalight, which is not in Riga but in province, and we turn around about 10 million annually for optical fiber applications. Their advantage is that they are using not this for communications but for medical applications, such kind of very specific use of optical fibers. And the advantage is that they have this quality moved to ultraviolet phasers and others produce. And there is an option that for medical applications there is a so-called single-used instruments to look inside you and so on and so on. And they had a chance at that time when I made this interview, they had a chance to capture USA market for this, and it was for them, they said, okay, it can come to 100 millions. And then there was no adequate reaction from decision makers.
Okay, before I would like to, before taking one more, thank you, before one small comment is that you look for a more wide view on photonics in Latvia, and just to remind that in Latvia photonics is, people to photonics is coming from different directions, and one very strong field is solid-state physics, and you mentioned, thank you, Institute of Solid-State Physics, where the material science is very strong. But material science part is partly materials are used in photonics, for photonics, so to say. And therefore, indirectly, photonics is in smart specialization strategy, because the smart specialization strategy is these smart materials, which are used for photonics. And historically, we do have very good cooperation with institutes in this field, also with companies. Somehow come out for both institutions. One, what I would like to tell, you are asking for that, I agree very much with that we, first of all, in Latvia, we must find common attitude to this problem, common attitude. And that the way as it was told in the future will be very much in high technologies, very much in photonics. So, with that, thank you.